We're going to finish 6.3, and we have to do determinants of a 3 by 3 matrix. This is 6.3, and you will have to find determinants of a 3 by 3 matrix by hand on your test. You will not have to find the inverse by hand, but you will have to do the determinant part by hand. We'll talk about two ways. The first way is called this expansion by minors. So right now we just have any entries, that's why they're just have those subscripts with them. Okay. So first thing we have to do is choose a row or a column. And you just choose one. So let's say we choose row 1. So in row 1, we have A11, A12, and A13. Okay? So each of those entries have an associated minor matrix. Okay. We also have some signs that go with these entries. So the sign matrix for a 3 by 3 this is for minors, okay? And I'll explain what the minor is in just a minute. So 3 by 3, it will alternate signs. So the first is always will say positive or a plus sign, okay? And then it alternates. So negative, positive, and then it's going to be negative, positive, negative, positive, negative, positive. So that's the associated minor signs. Okay, for a 3 by 3, that's what they always are. Okay, so if I'm looking at row 1, then it's going to be a plus, minus, plus. Think of the minus like opposites when you're doing this, so you're careful. Okay, so if I'm choosing row 1, my first entry is A11. Okay, A11 is part of the first row, first column. So what I'm going to do is I'm going to take that entry and multiply it by the determinant of its minor. So I cross out the row and column that A11 goes to, and then its minor is this 2 by 2 matrix that's left. So, and I'm going to use bars, not brackets, because I'm finding the determinant. Okay, so I'm going to do A11 times the determinant of that 2 by 2. Okay. Remember to find determinant of a 2 by 2. That is the part when you're finding the inverse, like you did on the warm-up, you found the inverse. That's the 1 over part, that AD minus BC. That's the determinant of a 2 by 2. So you'd be doing A22 times A33 minus A23 times A32. Get that number and multiply it by A11. Okay, so there's the first one. And then my next entry in row 1 is A12. Okay, so now I'm looking at A12 right here. So that's the first row, second column. A12 has a minus sign associated with it. And then its minor matrix that's left is what's not crossed up. So A21, A23, A31, and A33. Okay. Then my last entry in row 1 is A13, and that has a plus sign with it. So I'm looking at these two like addition and subtraction. I'm not going to actually, if it were negative, I'm not making it positive for the plus sign anyway. I mean, you could think about it if you have a minus sign, but you're think about it as addition and subtraction. Okay. So my last one is A13. So that's the first row, third column. So then what's left is A21, A22, A31, and A32. So again, I'm using the bars because I'm talking about determinant. So determinant looks like absolute value bars. All right, so this is the setup. And then remember what you're doing with these matrices and the bars is finding the determinant. So you're going to do A11 times the determinant, so A22 times A33. Remember AD minus BC minus A23 times A32. Okay, so you get a number here and multiply that by the A11 entry. Determinants are numbers. You're not going to get a new matrix. You're not looking for the inverse right now. You're just looking for the determinant of the matrix. So, and so on. You would do the same thing for the sorry, I left that 2, 1. A12. I left off the 1, 2 here. You do the same thing for the A12 and the A13. All right, so let's do an example. It'll be easier when you see actual numbers here, but that's just the setup here. You can choose any row, any column, but make sure you stick to the same one. So you don't do 2 entries from row 1 and then 1 from row 3. Okay, so choose 1 row or 1 column to do. Okay. So let's look at this matrix, and it wants us to use row 1, so we'll practice that. So we want to choose row 1. I have to know those signs, the addition or subtraction, so I know what I'm doing between each determinant. So that was a plus, minus, plus, so addition, subtraction, addition. Okay, so I'm doing 3 is the first entry. So 3 is the first entry. And then, so that's part of row 1, column 1. So my leftover matrix is 0, 5, 4, negative 2. That's its minor. Okay. Then my next entry in row 1 is 1, and that's a minus there. So I'm subtracting this one. 1 is part of row 1, column 2. So then the leftover numbers, I have -1, 5, 6, and -2. Can we see where we're getting these numbers? Okay. Then my last entry is 5. Right here. That's part of row 1, column 3. And that's a plus sign. So -1, 0, 6, and 4. So that's how we set up. And then we're just doing calculations from here. So be careful when you calculate. Maybe type things in your calculator if you need to. All right. So I'm going to do 3 times the determinant here. So that's 0 times -2 minus 5 times 4. So AD minus BC, that's the rule for a determinant of a 2 by 2. So if I go ahead and calculate this one, that's 3 times -20, so it should be -60. I would probably write them all out and just do all the calculation at once. You're less likely to make mistakes that way. So then, this is -1 times -2 minus 5 times 6. So you either are going to have minus -28, okay, because that's -28 inside, and there's a subtraction here, or you could change that to plus 28. There's a negative there. Just be careful with your signs. Okay, and then I have 5, so plus 5 times -1 times 4 minus 0 times 6. And so then that ends up being either plus -20, or you can have -20. All right, so you add those together, and you should get -52. So the determinant, so it looks like absolute value, but with matrices, remember that means determinant, is -52. Yes.
On the green part,
Yes.
I got -28 in parentheses.
So it's -1 times, right?
Yeah, so
That would be,
to do it, and then that'd be 28, but you still have the -1.
no, so when you subtract, you're either adding the opposite or subtracting the positive.
Because it's plus minus plus, so I thought
Right.
you would, because it's not positive 1, it's -1.
Okay, so if you're looking at it as -1, if you're subtracting 1, you're subtracting positive 1, right? Okay, so if you're subtracting positive 1, that's the same thing as adding -1.
Oh.
Yeah, be careful with the sign. When you look at your quiz, I still have it written over here actually. There was with one of the matrices on the back, there was some mistakes with that too. We'll talk about it though when I pass this out. Okay. All right. So let's do the same thing, same matrix. So I'm still going to get -52 as my determinant because it's the same matrix. But let's do column 2. This time we're going to do column 2. I'm looking here at column 2. Remember your signs. So the top left one is always the plus. So this would be minus, plus, minus. Okay, minus, plus, minus. These are changing these actual numbers, okay? These are only changing them like when we write out the addition and subtraction. So they're not going to be a part of the minors, but if they were, if you're looking, you're not changing all the signs of these, okay? This is just helping set up our addition and subtraction. Okay, so the first entry is 1, and I need to do a minus 1. Okay, so I'm looking here, so that's part of row 1, column 2. So that's negative 1, 5, so what's left is negative 1, 5, 6, and negative 2. Okay, the next entry in column 2 is 0. So that's going to end up just canceling that whole determinant. So when you're doing this, it's also a plus, so you're adding. That's row 2, column 2. Okay, so what's left is 3, 5, 6, negative 2. You're going to multiply by 0, and that's going to cancel. So whenever I would do this, I would choose a row or column that has a 0 if there's a 0 there. That makes your calculations easier. Okay. Then the third one is this 4, but there's a minus there. So that's part of row 3, column 2. So then what's left is 3, 5, negative 1, 5. Okay? And calculate the determinants of those minors. So that's 2 minus 30 is negative 28. Plus 0. I mean, you could write, if you wanted to write this down, that's negative 6 minus 30, negative 36. But that's going to be 0. And minus 4 times, that's 15 minus negative 5, 20. So again, I would be careful with your signs and try to type in as much as you can in your calculator. Okay, so you should still get the determinant. So you can write it determinant like this, the DET matrix A of negative 52. That means the same thing as the what looks like absolute value bars. Questions about that? Okay, I'm going to show you another way to do this, but I'll also show you, and we'll definitely use these more tomorrow. So if you didn't grab one today, that's okay. We'll use these tomorrow, because when you have to do 3 by 3 determinants, there's one question on your test where it says by hand, so you have to show your work. But you can always check it on the graphing calculator. But when we start 6.4 Kramer's rule, you'll have to be finding 3 by 3 determinants like 4 times. And so this would take a long time to do that over and over and over. So to save you time, then it'll be helpful if you could do it in your calculator. And I just wanted to show you where it is. So it's under matrix, but it's under the math section, and it's the very first one, DET. And then you would call up whatever matrix you wanted, which I'm just picking A. It's not this same one. So it was one I had typed in there previously, negative 37. Okay, so matrix math is where you find determinant, and we'll use that tomorrow. So when you come tomorrow, grab a graphing calculator because we'll be using it. All right, so let me show you another way we can do this by hand. So it does have the word shortcut in it. It does seem to be a little bit quicker. It's actually called column rotation, and the reason why is because we're going to take, kind of rotate some columns. Not really, because we'll just rewrite them. Hold on, I'm going to go back up in just a second. I just want to move this up. Okay, so here's our steps of what we're going to do. So this is the same matrix we just found the determinant, so I know that it's going to be negative 52 because I've already done this twice. And here's another way to do it. I'll give you a minute to write this down. All right, so when it says copy column 1 and 2, I'm just going to write column 1 and 2 to the right of my matrix. So column 1 was 3, negative 1, 6. Okay. Column 2 is 1, 0, 4. Right. So I want to find the product of the 3 diagonal coefficients from upper left to bottom right. So I have 3 diagonals now. So here, here, and here. So I'm going to multiply those together, the numbers, and then add each diagonal together. So I'm going to do 3 times 0 times negative 2. So that's the first one. Plus 1 times 5 times 6. Okay. Oh, sorry. Plus the third one, which would be 5 times negative 1 times 4. So the reason why I use the dots there is so I don't have like just tons of parentheses. So you multiply the numbers together in the diagonals, and then you add each diagonal together. Okay, so that was step 2. Step 3 says do the same thing, but we're going to start lower left. So we're going to start here. Okay, so that's 6 times 0 times 5 plus 4 times 5 times 3 plus negative 2 times negative 1 times 1. Subtract it from part 2. So minus in between this. Okay, and then I would just type all of that in again, so you just are careful with positives and negatives. So I should get 10 minus 62 which again is negative 52. So the only reason why we keep getting the same number for our determinant is because we're using the same matrix. It's called column rotation because if you didn't write these two columns here, then you got to kind of think about rotating like 3, 0, negative 2. Then is it 1 and 5 has to come back and rotate to get here with 6. Like that's kind of why it's called column rotation. I would just write the columns next to it. It makes it much easier. Questions about that? Okay, so what we'll do, we're going to practice a couple. So I'm going to give you a different matrix. And this says use expansion by minors. So the first way that I showed you. Because we're going to do it the other way, the column rotation, the shortcut. But I want to do the minors first. So take some time to practice that. But the correct answer fix it. Is negative 287. Okay? Okay? Negative 287. I want to do the same thing, so same matrix, but now do the shortcut, that column rotation method, so now try it that way. But you will also get negative 287.